Hello there. I started developing PrintShift on Prusa Minis in order to make the entire thing more accessible, so you don't have to build a custom printer in order to have a part ejector. However, I did not start playing with belt printers on a Prusa Mini. I in fact started on a printer belt, upgraded to a larger version of the printer belt, designed a larger version. Then I went to some Delta bots and ended up as my fancy test bed. This printer is known as Bad Horse. I'll discuss him more in a bit, but I wanted to go through a bit of the early development, how this sort of thing came to be. The first part ejector was developed by a MakerBot user, Charles Edward Pax, and his 2010 blog about it is still online. Yeah, he was working on a MakerBot Cupcake, one of the first commercial 3D printers. This was further developed by Charles as a MakerBot employee, and subsequently patented it, which is why I think most of the belt printers you're seeing today are angled bed, angled Z. Angled printers are ones where one of the axes is not perpendicular to the other two. I generally refer to Cartesian as this sort of machine where X, Y, and Z are all 90 degrees apart, each perpendicular to the others. This can also be used to enable infinitely long prints, or at least prints that are longer than the printer. The first of these was a project by Bill Steele that was unveiled in 2016 at the Rapid TCT show, and then shown again at 2017 Midwest RepRap Festival. To the surprise of everyone, it was actually a modified printer where he angled the bed instead of angling the printer. Followed fairly closely after by the Black Belt 3D Kickstarter. They must have been working on it before they saw Bill's prototype. Printer belt. So here we have the X-axis going back and forth, the Y-axis up and down, and the Z-axis marching across. The reason that you do this is the Z motor. That way when you're printing, you can have overhangs with no damage because they're being printed at a 35 degree angle. White Knight, which led directly to the Creality CR30, and the PowerBelt 3D, who also sell conveyor belts, so you can buy belts from them, custom sized, and place them on your own printer if you like. I did design my own scaled up printer belt, which is where I started to play with different conveyor belt materials. This is when the pandemic hit my shop, which left me with free time, a lot of odd printing parts, and a powerful need to print face shields. So I built two more belt-based part ejection machines, both Delta bots, Bertha, the large guy, and then Dr. Roxo is this little guy. And they're up here with pretty decent designs. After that, I wanted to explore the Cartesian with two axes so I could enable more fun printing. Thomas Sandlatterer captured my reasoning for moving away from the angled belt 3D printers in his lowered CR30 video. I'll throw the link up. And again with his real print bed automated Voron. Both are definitely worth checking out. The only reason I'm not going to go into print quality is, well, Tom's already got a good one on there. So, Bad Horse. Bad Horse was designed as a development printer to test out new conveyor belt ideas, and that's what I plan to use it for again going forwards. So this time, I'll record it so you guys can participate, make some suggestions. The unique feature of this printer is that its normal Y-axis is on a gantry, so while it's shaped like a Prusa-style bed slinger, it is in fact a fixed bed machine. The reason I designed it like that is because Novolab's build group printer, you notice it looks very similar. We were trying to make a high-end printer that doesn't break the bank. So you can see I reused a lot of the parts because that's the parts that I had in my shop. I don't really recommend that you build this model. It is up on GitHub if you would like to do so anyways. Certainly not going to stop you. I'll throw the links up. It's a cool idea and it does work pretty well, but the gantry is pretty heavy, so you're going to be speed limited. I think I could tune it a bit better than this, but I mean, it's not really the point of the machine. Now, we also have, point out, the bed is powered by two stepper motors, which are configured in the firmware as well. So I can move this bed very precisely. I can advance it, say, 0.2 millimeters, and pretend that the belt is the Y-axis instead of the gantry. So it really is three modes of operation. This is the first normal mode where the gantry is moving back and forth, and the bed is fixed. I can swap that around logically and move the bed back and forth while keeping the gantry fixed. Easy enough. The third option is what got me interested in this. I could move the gantry, I could move the bed a small amount as a printer belt, or an angled bed that works, and then use the moving gantry to print on a plane fine. So I could move the belt and define my own plane in the slicer. print purely rectilinear, or if I wanted longer parts, print them at a 10-degree angle if that'll be enough, 15, 30, all done in the slicer where you have a nice normal printer. And this could be done to really any fixed bed printer. I don't think you want to move the conveyor belt on a Prusa style, i3 style moving bed printer. However, you can find any printer off the shelf, throw a moving bed on it, improve the firmware. Probably going to install RepRap firmware on this so I have easier control of the axes, just honestly path of least resistance. First though, I'm going to be using this to test out new conveyor belts. Now that the PrintShift is working relatively well, I'm going to have that producing for a while and get back to some prototyping. In order to make angled slicing on this, probably work on a post-processor, so a G-code post-processor that is axis aware. First though, I'd like to use this machine to test out some new conveyor belts. I'd also like to get RepRap firmware running on the machine, make it a little bit easier to prototype on. If anyone interested in helping on Slicer post-processing script, trying to make something bed aware, do please let me know. We can define the project more thoroughly and throw it up on GitHub. Keep it as open source as we can. As always, happy printing.